Hello everyone, welcome back to Think Lab by Saurabh. So today we are going to discuss one of the most important concept in machine learning that is every data scientist should understand. The topic is class imbalance in machine learning. So if you have ever built a machine learning model that show 99% accuracy but still fail in the real world. So this video is for you. Let's get started. First, let's understand what is the class imbalance actually. So a data set is called imbalance when one class contain more sample than another class. For example, imagine a credit card transaction data set. So out of 1000 transaction, 99 are the legitimate and only 5 are fraudulent, right? So this means the data is highly imbalanced. The majority class is legitimate transaction and minority class is fraudulent transaction, right? So now you might think if your model achieve 99% accuracy, that is excellent. But here is the problem. Suppose your model predict every transaction is legitimate. It correctly predict 995 legitimate transaction, but it's missed only 5 fraud cases, right? So your model is still achieved the 99.5 accuracy. However, it detects zero fraud. So it means it is known as the accuracy paradox, right? The high accuracy doesn't always mean a good machine learning model. Why is the class is imbalance such a scenario problem, right? So because machine learning algorithm learn from the data, so when one class dominate the data sets, the model naturally become the bias toward the majority classes. So as a result, minority class example are often ignored. So this lead to poor recall, okay, and more false negative. So that is the model will be extensive business mistake, right? So let's look the some real world applications. So credit card fraud detection, so medical diagnosis or cancer detection or spam email filtering, cybersecurity, detections, and insurance claim fraud, manufacturing defect detection, customer prediction. So in all these cases, the minority class is actually the most important one. So if your accuracy is high, if your accuracy is not high, what matrix should we use? So first matrix is called precision. So precision tell us out of all predicted positive cases, how many were actual positive, right? Next one comes to recall. Recall tell us out of all actual positive cases, how many our model successfully detected. Then comes to F1 score, which is the balance of precision and recall. We also use the ROC-AUC and also PR-AUC, right? So and there is a like Matthew correlation coefficient and the confusion matrix. So this matrix provide a much better understanding of model performance than the accuracy alone. So now let's discuss how we can solve the class imbalance problem. Now let's discuss the how can we solve the class imbalance problem. So first approach is the random oversampling. So here we try to find a duplicate minority classes sample. This balance is the data sets, but it may lead to overfitting, right? The second approach is the random undersampling. The first one was random oversampling, and now we are talking about the random oversampling, right? So here we remove the sample from the majority classes and training to become more faster, but valuable information may be lost. The third one is the SMOTE, right, which stand for the synthetic minority oversampling technique. So instead of copying the existing sample, SMOTE generate the new synthesis minority sample. So this usually improve the model performance better than the simple duplications, right? Another powerful technique is called class weighting. So, instead of changing the data set, we assign the higher penalty when the model misclassify the minority class sample. So many algorithms include the logistic regression, support vector machine, XGBoot, light JVM, and neural network support the class weighting, right? So, next come to the cost sensitive learning. So in this approach, different mistake have different costs. For example, missing a fraud transaction is much more expensive. So then incorrectly flagging the legitimate transaction. So we also use assemble method. Example, balance random forest, easy assemble, right? So and the weighted gradient boosting model. So this model often improved the minority class predictions significantly, right? Another useful technique is called threshold tuning. So instead of using the default prediction threshold of 0.5, we adjust this based on the business objective. Okay, sometimes we increase the recall is more important than maximizing the accuracy. For extremely rare events such as one of the fraud case in 10,000 transaction, the random detection can be better solution than the transaction classification. So now let's look at the some best practices. Also always perform we always try to perform the train test split, right? Never rely on only on accuracy, monitor the precision recall, peer AOC, okay, ROC-AUC curve. Try class weight before the oversampling. Tune your classification threshold. Choose the evaluation matrix based on your business requirement, and also validate your model by using the confusion matrix. So let's summarize today's discussion. Class imbalance is one of the most challenging in real world machine learning. High accuracy can be misleading. The right evaluation matrix are far more important than the accuracy alone. We technique use the SMOTE, class weighting, oversampling, undersampling, threshold tuning, and the ensemble learning can significantly improve the model performance. Ultimately, the goal is not to build the accurate model, but build a model that can accurately identify the case that matter most. So if you found this video helpful, please like, share, subscribe to Think Lab by Saurabh, and let me know in the comment which technique you use most often for handling the class imbalance. Thank you for watching. I will see you in the next video. Happy learning.